So let us solve yesterday's problem. A variable line is passing through a comma b and it intersects x-axis and y-axis at capital A and capital B respectively. Now our variable is normally x, but we will consider it to be k, because if I write the equation of line AB, we will have an x there. So we should not get confused with that x. So for our area problem, what is the minimum area of AOB? That is the question solving. Our variable is. So what is the equation of this line? The equation of this line is x upon k plus y upon t is equal to 1. Is that right? And what is happening is a comma b satisfies this equation of line. Therefore, a upon k plus b upon t is equal to 1, makes it at plus bk is equal to 8. And we want to express t in terms of k because we don't want two variables. So this is the relation which will help us to eliminate t and get it in terms of k. So a minus k times t is equal to minus bk. Therefore, t is equal to bk upon k minus a. Hence, area of triangle AOB, area function A is equal to k into bk upon k minus a upon 2, which is b by 2 times k square upon k minus a. Okay, this is our first job. We have found out what function are we trying to analyze, the area function, and it is dependent on value of k. So if k is equal to a, if k is equal to a, line is vertical and therefore area will tend to plus infinity. K is equal to a. Okay, so that is correct. If k is equal to 0, k is equal to 0, area will tend to be 0. So our formula is correct. So now dA by dk is equal to v by 2 inside bracket k minus a into 2k minus k square upon k minus a bracket square. If we make it 0, we get k is equal to 0, or basically this is k square. What is this? 2k square minus 2ka minus k square is equal to 0. Therefore, k square minus 2ka is equal to 0. K inside bracket k minus 2a is equal to 0. Therefore, k is equal to 0 or k is equal to 2a. Is that okay? Now, by either first derivative test or second derivative test, I am not getting into finding out second derivative. We should figure out whether this is maximum or this is maximum. Because I know that this is minimum, the graph is going to be like this. So now we are into finding out what is the graph of this function. Numerator quadratic, denominator linear. That is what is this graph about. So okay, so this is a comma b. So this is a, this is 2a, and this is 0. So a, k is equal to a, not acceptable, therefore dotted line. Function is undefined. And to the right of a, if you put value little greater than a, then a is equal to some small value greater than a, then this fraction is going to be very small, and therefore the graph the graph is going to be asymptotic like this. At 2a, it is going to be minimum. So what will be the value at 2a? B upon 2, 4a square upon a, which is 2ab. So 2ab will be the value, and 2ab, let us say, this is not proportional diagram, so we have a horizontal tangent. So the graph is coming here. At 2a, it becomes local minimum, and then as you put values of k greater than 2a, it will go to infinity. What happens to the left of a? At 0, it is local maximum. To the left of a, you will find it disappears at minus infinity. That is why it is discontinuous function at a, and eventually if you put all values of x or k negative, you will go to negative infinity. This is what is the graph of the function. This is how this function, area function, is behaving. Now when we say that we are finding out minimum area, we mean it is a positive minimum area, and therefore our answer is this, and therefore I said it is almost correct. But really, if you do not have that consideration, then minimum area can be achieved by putting negative values of k, different negative values of k. The area is going to be moving towards negative infinity, and that is going to be we will not be able to find out the minimum. Therefore, local minimum is 2ab, local maximum is 0, and we know this can be achieved. I think that completes our discussion. Anything else that we want to find out here? Okay, I would like to give you a geometric proof for this. Doesn't matter whether your coordinate system is 90 degree or not. Suppose your coordinate system is oblique like this, and you are asked to, suppose point A comma B is given to you, and you are supposed to find out which particular variable line will give you minimum area. Then what you are supposed to do is complete parallelogram. Double this and draw line parallel to this and parallel to this from this point. Okay, so this second diagonal will give you the minimum area. This line will provide you the minimum area. Why? If possible, there exists another line passing through A comma B. Then by geometry, area of this triangle is equal to area of this triangle. So this triangle is, if we consider the green line, then what? This triangle is not there in the picture. You are adding this much extra area. Do you see this? This is extra area. If you draw any other green line passing through A comma B, you will have some extra area. The only line which will give you zero extra area is this line passing through these 2 points. Okay, and therefore in our case, because it is rectangular system, you are supposed to complete this diagonal. Parallelogram is a rectangle, and that is what is your minimum area line. when x is equal to 2a. This is the line which will give you minimum positive area. In oblique system also it is going to be this. So let me show you by drawing another line which is this way. So you are interested in this area of this triangle, but if you compare the area of this blue line triangle with this red line triangle, then this much area is unnecessarily added. Therefore, the minimum is the red one. That is what is our geometric proof for this problem. However, minimum area, if it is positive, it happens at 2a. And if negative areas are allowed, then minimum is not available. Okay. Now let us go back and complete a few more graphs, because I want you to really develop that skill of sketching and identifying the graph. When you know the function, you should be able to draw it very, very quickly.
सर पण मग आपण या क्वेश्चनचा आन्सर 0 पण म्हणू शकतो ना, म्हणजे मिनिमम एरिया विल बी 0.
नाही रे, हा म्हणजे म्हणू शकतोस तू. मिनिमम 0 कसं, मिनिमम मायनस इन्फिनिटीच्या साईडला चाललंय, त्यामुळे मिनिमम.
सर पण आपण जर म्हटलं की एरिया इज नॉट निगेटिव्ह तर मग
हा, एरिया इज नॉट निगेटिव्ह बट एरिया कॅन बी 0 असं म्हटलं तर मग 0 उत्तर बरोबर आहे. पण यू वांट एरिया टू बी पॉझिटिव्ह अँड देन इट शुड बी minimum, then 2AB is a correct answer. चालेल ना?
हो सर.
Now I do not know in what sequence I should give you this, but sorry. I have few graphs which we will complete. Next graph that you should draw is, say for example, 14, 10. e raised to minus x square झालाय ना तुमचं काढून. ओके, बरं हे कोणाला काय लिहून घ्यायचंय का? केलंय तुम्ही ऑलरेडी? केलेलं आहे, नो इश्यू. ग्राफ 1 फॉर टुडे. sketch y is equal to e raised to x plus e raised to minus x upon 2. Kada. To go about it, I mean, you can analyze it the way you want, but it is a simple graph because you know at 1 x is equal to 0, this is going to be 1. So there, when you put x is equal to opposite of x, the function continues to remain same, so it's symmetric about y-axis, even function, and therefore it is going to look like this. This is also called hyperbolic cos. This is cos hx. Now it is, I don't know, it is something similar to inversion, but see, when we have ellipse in 2D, eccentricity is less between 0 to 1. The moment eccentricity goes more than 1, ellipse gets divided like hyperbola. It becomes hyperbola like this. So maybe you can visualize that ellipse, when they are together, they form a closed geometry like this. At the moment you change the sign in between, the eccentricity changes and they go hyperbola. Hyperbola becomes opening outside. Now, our cos function was like this. Cos was like this, and cos hyperbolic goes that way. Yes, I am just trying to show you the similarity. This function is also defined as cos hyperbolic, and in 2D geometry MMR, you will find equation of this kind also somewhere mentioned. Sketch y is equal to e raised to x minus e raised to minus x upon 2. ठीक है, सागर आला है, त्याला नोटबुक घेऊन ये. Easy. So graph of this looks like this. This function is also known as sine hyperbolic. Sine hyperbolic. Three. Y is equal to e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Sketch. Okay, the graph for this. By doing whatever tools you want to use for sketching this graph, you use it, and eventually you will end up having y1 as one asymptote, y is equal to -1 as another asymptote, and then the graph is like concave here and convex here. Fourth in the family is y is equal to e raised to x plus e raised to minus. Okay, this is called tan h, tan hyperbolic x. So of course now I am going to give you cot hyperbolic. Sketch cot hyperbolic. Okay, the graph of cot h x is like this. At 1 it is asymptotic, at -1 it is asymptotic, at 0 it is undefined. Okay. Later sometime we will study or write down different properties, how these hyperbolic functions behave, what are the properties of summation, product, etc. Fifth problem. 2 sine x plus cos 2x. Now you need to do proper detailing of this function, and I want a graph for x belonging to closed interval 0 to 2 pi. Okay, and proper detailing. I mean, by looking at your sketch, every information should be known. The one who is observing your graph. Take your own time. Okay, as it is a trigonometry function or compound trigonometric function, addition of two trigonometric functions, finding derivatives is not difficult. Maybe you will get long derivatives first and second, but it should be easy, and therefore getting maxima minima specific points is going to be easy. So the graph eventually will look like this: x-axis, y-axis, 0 to 2 pi. Then this is pi, then this is pi by 2, this is 5 pi by 2, this is pi by 6. Three pi by 2. Okay, then 1, this is 1, and this is 1.5, 3 by 2. Okay, so the graph will start from 0, then it will achieve maximum. I mean, it is not proportional, but let me complete with this setup. It will start here, it will achieve maximum, then it will achieve minimum at this point, then it will achieve maximum again at 5 pi by 2, then after pi it will intersect this y is equal to 1 somewhere, and it will go up to -3. And go and end at 1. Something like this. And I have not drawn it very smooth or symmetric, but it is difficult. Okay, so the graph is going to look like this. This is pi by 2, this is pi by 6, this is 5 pi by 2, and this is 3 pi by 2. बघा जमते का? That is how it is going to look like. Question number 6. Little different now. X raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. Where a is constant. Now this is not function. This is the relation. I mean, this is how x and y are related to each other. What will be the geometric sketch of this function? If we want to sketch this curve, then which are the things that we need to consider very quickly? Maybe the first thing that you should consider is the extend. Extend. If for large values of x, what will happen? For large values of y, you want what? This is constant RHS. So if x is equal to 0, y is equal to a. Now you can write this function as cube root of x square plus cube root of y square is equal to constant a raised to 2 by 3. This is constant. So if I put x is equal to 0, then what will be the value of the function plus or minus a? 0 comma a. 0 comma minus a. These points are there on the curve. If I put y is equal to 0 plus or minus a, these are the points which are on the curve. A comma 0, opposite of a comma 0. Good. So this is the. Can I put value greater? Suppose I put x is equal to 2a. Then this is not going to give me, I mean, I cannot subtract, and this has to be non-negative number, y square, therefore it is going to be 0 or positive number, and cube root of positive number is going to be positive. Therefore, I cannot make this value less. So these are the boundaries. Practically, your function or the graph will not exceed these values. So that is what is the very important analysis which we need to do immediately. The extent is done. So whatever is going to happen is going to happen in this square. Now, if I replace x by opposite of x, I get exactly same function. Therefore, the graph is going to be symmetric about y-axis. If I replace y by opposite of y, I am going to get exactly same function. Therefore, it is going to be symmetric about x-axis. So if you sketch in first quadrant, you have to reflect those sketches in x-axis and y-axis to get remaining 3. Suppose we put x in place of x, opposite of x, and in place of y, opposite of y, then that point is also on the curve, therefore it is symmetric with respect to origin also, right? So now maybe what you can do is, in the first quadrant, maybe x value is from 0 to a, you find out the slope and you will find that the nature of the curve between these two values. Okay, maybe first derivative or something you have to find out to figure out how this function will be between these two values. Maybe what will happen is at a tangent becomes horizontal if it is only a first quadrant function. If we take, is the tangent horizontal here?
Yes, sir.
Yes. So this is the clue that at a the tangent is horizontal. Now if we have a curve like this, on x-axis the tangent cannot be horizontal. Here it is going to be horizontal. So that is the clue that you can have and get the curve, and then reflect that curve in x-axis to get this arm, reflect in x-axis and y-axis to get this arm and this arm. So this is called asteroid. We will learn these curves when we actually do application of integration. Okay, we will draw or we will develop these curves. What is the geometry that gives us these curves, etc. We will find out. But at the moment we are just using differential calculus. We are trying to sketch the curves, and this is how it is going to be. Any doubt, difficulty? No. Good. 7.
सर
Yes.
सर ते म्हणजे 0 आणि ए मध्ये कर्व कॉन्व्हेक्स की कॉन्केव्ह कसं काढलं? कारण मी म्हणजे मला
सेकंड डेरिव्हेटिव्ह काढून चेक केलं तरी सुद्धा कळणार हा कॉन्व्हेक्स आहे की कॉन्केव्ह आहे ते. आणि दुसरं म्हणजे ए ला हॉरिझॉन्टल टँजंट जर असेल तर तो असा आयदर स्ट्रेट लाईन किंवा कॉन्केव्ह येऊन इंटरसेक्ट होणार नाही ते. त्याच्यावरनं त्या दोन गोष्टींवरनं चेक करायचं. Between 0 to a, you can analyze this function. You can express it y as a function of x and find out y dy by dx and analyze. If that is the work, that is the only work. Otherwise, all other information we do get by not doing anything. Just putting values and checking symmetry, extent, all that. Only efforts are required to check whether it's concave or convex in this region, and therefore you have to use derivative for that.
Can we take log of both sides, like in
Sorry?
the equation? So log of both sides. So if we take log on both sides, then we get something like log a is equal to log xy.
Log a is equal to
Log xy.
9. Log of m into n is equal to log of m plus log of n. I think you are mistaking in this. Taking log will not help because log of summation we don't have anything. Okay, log of product will convert it into summation. I think you are making mistake, Harshita. Y square is equal to x cube. Sketch quickly now. Now you have experience of sketching something like this. Do it quickly. Now, as it is square of y in LHS, you can explicitly actually write it as a function. So these are going to be two functions. Y is equal to square root of x cube, or y is equal to minus square root of x cube. Correct? And therefore they are reflections in x-axis. So if you take one and analyze it and draw, it is the reflection in x-axis. That is what is this function. So both put together is this explicit, not explicit, implicit function. So if you analyze this is x raised to 3 by 2, y is equal to, so dy by dx is equal to 3 by 2 x raised to half. Correct? So if you put x is equal to 0, dy by dx is 0, and therefore at 0, your tangent has to be horizontal. Can you have negative values of x? No. Then y square is always positive. So to the left of 0, you don't have any. Can you have only positive values of x? Higher value, as x tends to infinity, y will tend to infinity. Right? So it has to be horizontal, and therefore it is fixed that it has to be convex like this. You don't have point of inflection here. Why second derivative is not going to give you any value of x, where second derivative is going to be 0. Is that right? Because this x will get into denominator. So this is one arm, and reflection of that in x-axis is going to be another arm. Wherever it is positive, you make it negative. Semi-cubical parabola. Okay, good. Sketch number 8. Y square is equal to x raised to 4 minus x raised to 6. Sketch and show. Okay, again similar kind of analysis. Y square, so basically two functions. Y is equal to x fourth minus x sixth raised to 1/2, and opposite of x fourth minus x sixth raised to 1/2. So if we do work above x-axis, we can reflect it in the x-axis to get the second one. Simple. If we put x is equal to opposite of x, function does not change. This, say for example, this function does not change. Therefore, symmetric about y-axis. Now, as far as finding out derivative, equating it to 0, all these things you need to do. Second derivative, checking. So there are points of inflection. There are maximums, minimums. If we take this function, the sketch is going to be like this. Extend. Will value of x be greater than 1? Suppose we put x is equal to 2, we will keep continuously getting y is equal to negative, because 2 raised to 6 is going to be bigger than 2 raised to 4, and we will end up having a negative value. Therefore, our extent is, we cannot go beyond 1. Good. If you take a couple of derivatives, you will see that there has to be horizontal tangent, and hence the graph is going to be like this. You will get some maxima somewhere, maximum at some point here, and you will get, because at x is equal to 0 you want convex, at maxima you have concave, therefore you will get some point of inflection somewhere in between. Vital. Now, if this is extended, you will find that at x is equal to 0, the derivative also will be undefined. बरोबर है? So the tangent at 0 is going to be vertical, and this is what is to be reflected in x-axis. Difficult, but I will. Something like this reflected here also. All these values are also fixed. Both are same. It is a symmetric infinity type of symbol, but you have tangents at origin, horizontal tangents. Local minima for this function, and this is going to be local maxima for this function. There will be some point of inflection somewhere. If you want the value, it is going to be root 2 upon 5. Will give you point of inflection. Maximum is root 2 upon 3. Value of the function maximum 2 upon root 3.
सर ते √2/3 नाही 2/√3
Huh?
सर तो मॅक्सिममचा पॉइंट 2/√3
2 by root 3.
√2/√3.
Yes, sir.
Maxima point काय आहे?
So square root of
√2/√3
Whatever I have written is not correct.
सर खाली
2/3 full square root.
root
Acha, full square root. Huh? Here also. I mean, you are not aware because you have not drawn point of inflection. Okay, whatever. I mean, you just find out those values, and the curve will look like this. Question number 9.
So,
Yes.
so could you please explain why the tangent at 0 is horizontal?
Yeah, you differentiate this, na? What is y dash of upper positive curve? Half into x fourth minus x sixth into derivative of bracket, that is 4x cube minus 6x raised to 5. Is that right? So this is the derivative. If you put x is equal to 0, we get 0 at x is equal to 0.
But that x raised to 4 minus x raised to 6 will come in the denominator, right?
Why?
So because half into x raised to 4 minus x
Ah,
raised to 6.
oh, so yes, raised to minus half. Minus 1 I have to, yes. And it will go in the denominator. Let me write down. So 4x cube minus 6x raised to 5 upon x raised to 4 minus x raised to 6 raised to half into 1 by 2. Okay. So if we put x is equal to 0, then what is happening? That is good question. So derivative at that point is y.
Sir,
Ah,
sir, before differentiation, we can take x raised to 4 common. And
आणि फरक पडतोय का? y is equal to x raised to 4 चा स्क्वेअर रूट म्हणजे x स्क्वेअर इनसाइड ब्रॅकेट 1 minus x square raised to half असं म्हणतोय.
तर y डॅशच्या न्यूमरेटर मधनं x स्क्वेअर आणि डिनॉमिनेटर मधनं x फोर्थ कॅन्सल करायचं.
Sir, instead of doing all of this, we can just say that derivative of 0 is y of x minus y of 0 upon x minus 0 as x tends to 0. That easily gives us the answer.
From every way, I mean, whatever way you choose to do that, you should get derivative at 0. If the graph, I mean, if what graph or sketch that I have drawn is correct. Okay, so what somebody is saying is you take out x fourth root, so x square common here, 2x square inside bracket 1 minus x square, that is what remains inside the denominator, and you can take x cube common or maybe 2x cube common. So what remains is 2x cube inside bracket 2 minus 3x square. Okay, so what we get here is 2 gets cancelled, half is already there. No, so that is x into 2 minus 3x square upon 1 minus x square. And if we put x is equal to 0 here, we get derivative equal to 0. Is that okay? One way you should show that derivative at x is equal to 0 is 0. This is by
Yes, sir.
principle what Pranav is saying, by first principle. Here it's a derivative, here first simplify and then take derivative. One and the same. Everything is exactly equivalent. Question number 9. There will be a lot of errors in this sketch. So you have to check for yourself before showing it to me. Y is equal to e raised to x. Okay, if x is greater than 0 and to the right of 0, at x is equal to 0, the function is not defined. So let us have horizontal, the hollow circle there. If I put say 0.1 e raised to 10, it will become. If I put 0.01, it will become e raised to 100. So the graph will enter to the right of 0 like this. Okay. And as I put higher values of x, this is going to tend to 0, therefore e raised to 0 is going to be 1, and hence you have a asymptote at x is equal to 1. And therefore this nature of this curve, therefore nature of the curve here is going to be like this. Okay, so that is positive values of x, it is easy to evaluate. There is no point of inflection etc available here. I mean, if you do double derivative etc. Now if I put x is equal to minus 0.1, then it is minus x is equal to 1 upon minus 0.1, makes it minus 10, e raised to minus 10, makes it 1 upon, how much it is? 1 upon e raised to 10. So it is a very small value. This is very small value, and as I go near x, this is going to be smaller and smaller. So the graph is expected to be in near x-axis in the neighborhood of 0. That is one analysis which we can do from here. And as we go, as x tends to minus infinity, what will happen is it will be minus 0. Again, it will be asymptotic with the same line. Now, when we say asymptotic with the same line from bottom, it has to be concave. So I am writing slight concaveness there. Okay, what is y dash? E raised to, how do you differentiate this? Log y is equal to 1 upon x. So 1 upon y dy by dx is equal to, this is x raised to minus 1. So minus x raised to minus 2. Okay. So dy by dx is equal to y times e raised to 1 upon x with negative sign upon x square. So if x is equal to, so slope near 0 to the left of 0. So if you put x is equal to 0.1, will this quantity be 0 to the left of 0? To the left of 0, in the left side of 0, not at 0. At 0 it is undefined, so it is gone. But if we put 0.01, then this will become 0.0, 0.2. If we put x is equal to 0.1, then this becomes 0.01. I'm just estimating, just getting feel what is happening. Then this is minus e raised to, I am putting x is equal to minus 0.1. So it is going to be e raised to minus 10. Therefore, minus of 1 upon 0.01 times e raised to 10. Is that correct? So this is 100 upon e raised to 10. This is going to grow, right? As you go near x, this is going to grow, and therefore the dy by dx at x is equal to 0 to the left of x is equal to 0 is going to be 0. So you have a function like this near 0, and this is concave, this is going to be convex, and therefore you will end up having a point of inflection somewhere, which you can find out by differentiating this again and equating it to 0. It will be somewhere here, and that is what is it does not go and hit this. I mean, if you are drawing it like this, then it is not correct, because there is a point of inflection, there is a tangent to the left of 0. Head bit. समझते correct सगळ्यांना? Okay, so the graph I have explained. We have still 16 minutes, and we can draw a couple of more graphs. Problem number 10. Y is equal to x plus 1 upon x. Yes.
तर 9व्या ग्राफला पॉइंट ऑफ इन्फ्लेक्शन साठी एक्स -1 किंवा +1 येत होता. तर -1चं कळलं, पण +1 ला पॉइंट ऑफ इन्फ्लेक्शन नसणार ना, मग ते रिझल्ट चुकीचा आहे.
मी काढतो आणि चेक करतो. ठीक आहे. Okay, problem number 10. Sketch is going to be like this. Actually, you can physically draw. You can draw y is equal to x, and you can draw y is equal to 1 upon x, and point by point you can add them. However, you can use our differential calculus tools to sketch it. This is one asymptote, and the graph is going to go like this. This is local minimum at x is equal to 1. When both are equal, AMG. And why should it not be symmetric with respect to origin? If we put x is equal to opposite of x, then y becomes opposite of y. Right? So it is symmetric with origin, and therefore it goes like this. So local minimum at x is equal to -1. Okay, so this is the graph. I think it is easy. Let me give you the last one. Last one in the series, 11. Y square into a plus x is equal to x square into a minus x. That completes our theoretical discussion, except those approximations rate measure or something like that. Okay, we will sketch later on, and this is little involved to do lot of analysis for getting the correct sketch of this curve.